To create a VB.NET application that will translate an EDI file, we first bring up Visual Studio.NET, and in a new project we reference the threaded component by going to the menu, select Project, Add Reference, then under the .NET tab, look for the EDI Dev Framework EDI.NET. Select it, then hit OK. We can see EDI Dev Framework EDI.NET under References once it's been selected. Next, we add a button. Give it an appropriate name. And then double-click on it to get to the source code. The first thing we do in our code is to add a line to use the EDI Dev Framework EDI namespace. We do this in VB by typing imports edidev.framework EDI. From here on, rather than typing all the codes under the button click from scratch, I'm going to bring up an EDI program which I've already created that translates an EDI file. I'll just explain the source code as we go through each line. Before we can actually write any code, we need to open up our trading partner's implementation guideline so that we know where in the EDI file the data we need are located. I'll also open up the same Ceph file that our program will use with the Ceph Manager utility so that we can reference the guideline as well. Ceph files are implementation guidelines, but in a standard format so that programs can parse and use them. Also, make sure to obtain a sample EDI file from your trading partner so that you can have something to test with your program. Open it with the eFile Manager so that you can reference it as you program your application. Now the logic to the translation program would be to traverse through the entire file, reading each segment at a time, and pulling the values out from their data elements. So the first segment we read would be the ISA segment, which we would then get its values. The next will be the GS segment. Then we pull its values, and so on. So in our program, under the button click procedure, we first declare the OEDI-doc object to represent the entire EDI file. Then an O segment for the segments that make up the EDI file. We instantiate the OEDI-doc object, then load the schema of the EDI file we will be translating, which would be the 835x091 Ceph file. Next, we load the EDI file. Now, our algorithm to traverse through the EDI file is to initially read the first segment, which would be the ISA segment. Then have a do-while loop until there is no more segments. Inside the loop, we have the O segment dot next that reads the next segment. When we read a segment, we have to identify it first, we can uniquely identify a segment by checking these three properties: the area, the loop section, and segment ID. If we reference the CEF file, we can view these properties here. This is the segment ID. In here, the area that can have values 0 for segments in the envelope, 1 for header, 2 for detail, and 3 for segments in the summary. And this holds the value for the loop section. So for example, this REF segment has an ID of REF. It is in area 1, and since it is not in any loop, the loop section is null. This other REF segment is in area 2, and its loop section is LX semicolon CLP, because it is in the CLP loop nested in LX. Let us view the sample EDI file to see how our program will translate it. We see that the first segment in the ISA is the ISA, and it's in area 0 with no loop section. So in our source code, we have these if-else conditions to check for these properties. The first checks for area 0. This one checks if the loop section is null. This checks for segment ID ISA. Once we know we have the correct segment, we get its value by calling the data element value method and passing the element position number in the first parameter. So this gets the value of the first data element, this the second, and this one gets the 13th data element, which has the interchange control number. If we go back to the eFile manager, this would be the data element. And we do this for all segments. We check for their area, loop section, then segment ID before obtaining the values of their data elements. In some cases where there are several instances of a segment or loop, example, this N1 loop, just checking for the area, loop section, and ID is not enough because both instances will have the same values because they are of the same segment or loop, but is just being repeated. This N1 is in area 1 and has a loop section N1. This other N1 is also in area 1 with a loop section N1. So both have the same values in their loop section and area. So to differentiate the two instances, we have to check for their qualifier or entity identifier. In this case of the N1 loop, the entity identifier is the first element of the N1 segment. The first instance has an entity identifier code of PR. The second instance has the entity identifier code of PE. So the source code to translate these loops would be to first get the entity identifier, which is in the N1 segment in data element 1. We then set up conditions to check for them. This checks for the identifier PR. This checks for PE. Once we've differentiated between the two instances, we can interrogate the segments of that instance. This N1 loop instance has the N1, N3, N4, and REF segments. Also in this example program, for the sake of simplicity, I've just added a list box to store the data we've obtained. So this line here will add the value for this particular data element into the list box of this form here. You would, of course, create your program to store these values into a database. Let's run this program. We first compile it, then we run it in debug mode. When we click on the Translate button, the sample EDI file gets translated and the values obtained are stored here in the list box.